Here, and today we're going to be doing Unit 4 Notes 2. So today we're going to talk about factoring by grouping. So we're going to be using some of the skills that we learned yesterday when we talked about pulling out the greatest common factor. That's going to be really important in what we do today. So let's go ahead and start by taking a look at factoring by grouping. So to start off with, when we do factoring by grouping, we're going to use basically that idea of the distributive property, and this method of factoring, this factoring by grouping method, is typically used when we have four terms. Okay, so we're going to be kind of taking a look at how we can use the distributive property to factor by grouping when we have four terms. If you need more time to write that down, feel free to take that time. So here are kind of the steps that we use. I always suggest that you write these steps down so that if you're stuck on a problem, you can kind of reference back to your steps and see kind of maybe what you have left to do so that you know what your next step is if you're stuck. You can kind of see where the next point is that you need to go. So the first step is to group the terms into two groups of two. So you can put the first two together and the second two together. The next is you're going to pull out the greatest common factor, or the GCF, of each group. So you're going to figure out what number divides both of the coefficient and how many of each letter you can pull out. Remember, when you take out a greatest common factor, you have to take the same amount of things out of each term. For number 3, you want to check and make sure that your leftovers are matching. So when you take out a greatest common factor, you're going to have probably a binomial left over. And you want to make sure that those two binomials are matching. If they're not matching, then you did something wrong. The next thing we need to do is factor the leftovers out like they are a greatest common factor, because they're each being multiplied by the greatest common factor, so we can factor them out. Last but not least, you're going to write the two factors out. Now that sounds like a whole bunch of mumbo jumbo, so let's go ahead and take a look at what that'll look like in practice. So let's take a look at number 1. So for number 1, the first step is to split it into two groups. So that's what I'm going to do to start off with. I'm going to put this group, and then I'm going to put that group. So then I'm looking, okay, and I'm asking myself, what divides 8 and 64? Well, the answer is 8. Next, I'm asking myself, I have 3 r's and I have 2 r's. So how many r's can I take out of each term? And that's going to be r squared. So when I divide each of those out, I'm left with r, because 8 divided by 8 is 1, and r cubed divided by r squared is just r. 64 divided by 8 is 8, and those r squareds are going to cancel. So I'm just left with r minus 8 there. Then, for my second term, there is no GCF. So what I'm going to do is I'm going to take out a GCF of 1, which really isn't like taking a GCF out at all, but I'm going to write it so I know that it's there. And then that r minus 8 is going to stay the same. So what you should notice right now is these two parentheses that are left over are matching. They're the same. That means we factored by grouping correctly. So we can pull this r minus 8 out. And then we're going to write what's left over after that, which is 8r squared plus 1. So that right there is your final answer for that one. Okay, let's go ahead and take a look at number 2. So for number 2, we're going to, again, create our two groups. So between 12 and 21, I can divide out a 3. Between p cubed and p squared, I can take out a p squared. So now I'm going to take each term, each coefficient, and I'm going to divide each coefficient by 3. 12 divided by 3 is 4. Then I have 3 p's here and 2 p's here, so I'm going to be left with a p. And then 21 divided by 3 is 7, and p squared divided by p squared is going to cancel out. So I'm going to go ahead and write on the next line because I'm kind of running out of space here. So between 28 and 49, I can pull out a 7. And I can't take p's out of both terms, so that p has to stay there. So then I'm basically dividing both of those terms by 7. 28 divided by 7 is 4, and again we'll keep the p there. 49 divided by 7 is 7. So if you notice, again, those two leftovers are matching. So I can go ahead and I'm going to factor those out as if they were a greatest common factor, because they are. Okay, so once I've factored those out, I'm going to write in the parentheses what's left after that. And that gives me 3p squared plus 7. And that right there is our answer. That's our factored form. So we take the two binomials and make sure that they're written out all multiplied together. Next, let's go ahead and take a look at number 3. So again, we're going to create our two groups. So between 12 and 2, I can only divide out a 2. And I have 3 x's and I have 2 x's. So I can divide x squared out of each term. So basically, I'm dividing each of those terms by 2x squared. Well, 12 divided by 2 is 6. X cubed divided by x squared is just going to give me x. And then 2x squared divided by 2x squared, that doesn't cancel out to 0. 2 over 2 is 1, right? So that actually cancels out to 1. So if you take out your GCF, and that's the term that's there, then you're going to write a 1. It doesn't cancel out to 0. Now, what I notice is that there's a minus sign in the middle there. So if there's a minus sign in the middle, I know that for my middle term, I'm going to take out a negative GCF. So between 30 and 5, I can take out a 5. So now when I go to factor out my GCF, I'm actually going to be dividing each term by a negative 5. So negative 30 divided by negative 5 is 6. And again, the x is going to stay there. We can't take out a GCF of x because there's not one in the second term. Negative 5 divided by negative 5 is positive 1. So by taking out that negative, it worked out that our leftovers had matched. Now, if you didn't take out the negative, they wouldn't have matched, so you know you did something wrong. So we have 6x plus 1 and 2x squared minus 5. Once we write out our two parentheses. So you write first your leftovers, and once you've written out your leftovers, you're going to write which parenthesis, what was left over, which was the 2x squared minus 5. Let's take a look at number 4. So for number 4, again, factoring by grouping. Between 6 and 16, I can take out a 2. Between v cubed and v squared, I can take out a v squared. 6 divided by 2 is 3. V cubed divided by v squared is v. 16 divided by 2 is 4. And the v squareds are going to cancel out. So that's good for my first parenthesis. For the second parenthesis, I have 21 minus 56. Okay, so 21, I can take out a 7 between 21 and 56. So I'm going to divide out a 7. So I'm basically dividing each of those terms by 7. 21 divided by 7 is 3, and then v. 56 divided by 7 is going to give me, oops, this should be an 8. Because this should be an 8. Yes, ladies and gentlemen, 16 divided by 2 is 8. I am well aware that was a small mistake. So now we see that our leftovers are matching. We have 3v minus 8. So we're going to pull out that 3v minus 8 because our leftovers are matching. We can take them out like a greatest common factor. So when I get rid of those, in my second parenthesis, I'm going to write what's left over, which is 2v squared plus 7. So 3v minus 8 times 2v squared plus 7. Let's keep moving on. So right now I'm going to go ahead and we're going to take a look at number 5. So for number 5, we want to factor by grouping. So again, I'm going to make my two groups. Between 4 and 12, I can divide out a 4. Between v cubed and v squared, I can take out a v squared. And then left over when I divide that out, 4 divided by 4 is 1, v cubed divided by v squared is v. You can write the 1 if you want to, but you don't have to. Okay, so then we're going to go ahead and next 12 divided by 4 is going to give us 3, and those v squareds are going to cancel out. Next, I notice that I have a negative GCF in the middle, or a negative sign in the middle there. So I know I need to take out a negative GCF. So I just write that there to help remind myself. So between 5 and 15, I can take out a 5. So now I'm dividing each of those terms by negative 5. And when I do that, I'm left with v minus 3. Negative 5 divided by negative 5 is going to be a positive 1, or you could just write the v. So now I notice that my leftovers are matching. So I can go ahead and I can pull out those factors. Now I'm going to cross those off, and I'm going to write what's left over when I do that, which is 4v squared minus 5. So this right here would then be your fully factored form. Let's take a look at number 6. So for number 6, we're going to keep factoring by grouping. So we're going to take this, 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 this. So between 49 and 35, I can take out a 7, and I can also take out an x squared. So when I divide that out, I'm left with 7x minus 5. Okay, so we're dividing the coefficients and then figuring out how many exponents we have left when we divide them out. We can't take an x out in the second one because there isn't an x in each term. 56 minus and 40, the 8 divides 56 and 40. So again, that's just using that GCF stuff we talked about on the previous note sheet. So this is going to be 7x minus 5 when you divide each of those coefficients by 8. So if we check, our leftovers are matching, so we can go ahead and write that out. And then once we take out our leftovers, we're going to write what's left after that, which is 7x squared plus 8. So that right there is our fully factored form. So let's take a look at a couple more examples, and I'm going to have you try the last few on your own. I want to do at least 2 more for you. So let's take a look at number 7. So for number 7, again, we're going to factor by grouping. This time we have multiple letters, but that's okay. It's still going to be the same thing. So between 12 and 3, I can pull out a 3. So I notice that each of the terms in that first parenthesis, you're just focusing on the first parenthesis to start off with. Each of the terms in the first parenthesis has an x squared. So I can take an x squared. Well, the second term doesn't have a u, and the first term doesn't have a v, so those have to stay in there. So now I'm dividing each of those terms by 3x squared. Well, 12 divided by 3 is 4. The x squareds are going to cancel, so I'm just going to have u. 3 divided by 3 is 1, and we don't really have to write that because we have the v. You could write 1v, or you could just write v. Either way is okay. Between 28 and 7, we can take out a 7. I notice that there's a y in each term, so I can pull out a y. And then the u and the v cannot get pulled out, which is okay because we have a u and a v in each of our terms in the first parenthesis. So these two ended up to be the same when I divided each term by 7y. So then I can go ahead and I can factor those out. So I have 4u plus v, so I pulled those out. And next I have 3x squared plus 7y. So now I can write that out as well. Oops, and this should be multiplied, not. Let's see if I can write that out a little bit better for you here. Okay. So we have 3x squared plus 7y. There we go. So that would be your final answer for that one. So next, we're going to go ahead and let's take a look at number 8. I'm just going to erase this so I have a little bit more space. Okay, so for number 8, again, we're going to factor by grouping. So between 40 and 25, you can take out a 5. Now I notice each of those terms have an a, so I can take an a out of each term. So now I'm going to divide each term in the first parenthesis by 5a. 40 divided by 5 is going to give me 8. My a's are going to cancel, and I'm left with c squared. I couldn't take c squared out because it wasn't in both terms. 25 divided by 5 is 5. Again, my a's cancel out, and I'm left with k squared. Between 32 and 20, I can take out a 4. So I'm going to take out a 4, and I notice that each term has a b, so I can also take out a b. 32 divided by 4 is 8, and then we're going to have the c squared. 20 divided by 4 is 5, and then we're going to have the k squared. I apologize, I kind of ran out of room there. So we notice that our leftovers are matching. So I can go ahead and factor those out. So I have 8c squared plus 5k squared. And then when I cancel out those leftovers, I'm going to write what's left after that, which is going to be 5a plus 4b. So that right there is your final answer. So what I want you to do is to try the last 4 on your own. We'll talk about some of them, if not all of them, in class. So do the best you can, and please let me know of any questions you may have. Thanks for listening.